Sounds good.
Okay. Well, here we are. GP, good to meet you. I was just saying before I hit the button that we kind of missed each other because you were at Sensors Converge and I was in Italy getting ready for a Milan event, but I'm sure we'll meet in person at some point. But welcome to our Edge AI partner podcast.
Pete, it's very nice to meet you. Thank you very much for having me here in this, and I'm very excited. It's a great organization. A lot of great companies are coming together in this. So I'm very excited to be here.
Yeah, great. And one of the things I like about the foundation community is we have such a variety of companies. I was talking earlier about some people call it the stack. I call it the sandwich, the Edge AI sandwich of silicon IP and silicon and firmware and OS and models and data sets and models and solutions, blah, blah, blah. So there's this whole stack, and we try to represent the whole stack, and also from like kind of big tech to more startup-y, because this is such a nascent space. There's so much innovation happening, and I think something that you guys represent for sure is like innovating in this kind of semiconductor space about accelerated ultra low power AI, right? Give us kind of your, I'm sure you have a well-practiced pitch, but what's the origin story behind Ambient Scientific?
Okay. I have discussed this in a couple of podcasts before. Ambient's starting point, Pete, is actually more personal than anything else. I mean, for me, or part of my team, AI hardware is not new. We were working with a company that actually was building a large chip for servers, and they were actually later on building the entire system. This was to compete with NVIDIA or other companies like NVIDIA. At that time, there were many aspirants, including Intel, AMD, and a lot of startups as well. I'm talking about 2014, 2012, 2014. Okay. So at that time, I had a personal accident in my family where somebody fell, and I don't want to, it's kind of painful for me. So somebody fell and hit his head, could not survive. And that was, for me, that was a wake-up call. Yeah. Go do something about it so that at least my other family members in future don't get into same trouble. So the idea was to kind of design or find out a very small device that I could give as a wearable to people, and it can detect intelligently, or it is intelligent enough to detect if somebody falls, and intelligent enough to differentiate it from a simple jump activity or normal day-to-day activity.
Right.
That took us down the AI route, because only the deep learning algorithms can be advanced enough to make such differentiation. Right. But then that took me the route of needing to build your own chip, because there was no chip available that could last for a very long time. One of the requirement I had, Pete, was that it needs to work on a simple battery or a small battery for many months. And there was no chip available, so we started building a chip. Little did I know at that time that competing or building a large chip for NVIDIA is easier. Building a small chip that can run deep learning algorithm and still consume very less power, that's actually a more difficult task to do. So we had to invent things. The problem about building a chip, Pete, is that the moment you have to build a chip from scratch, then it has to be a big funded company.
Sure.
Not have one of
non-trivial investment in time and money and people.
And so this is where you will see we have differentiated quite a bit from most of the edge, most of the members of this foundation.
Mm.
I mean, it's a good way to get into how we kind of become different.
Mhm.
I have been doing chip for a very long time, and most of my experience and part of my team's experience has been in microprocessors, very large microprocessors, like for servers or even for small computers, but programmable chips that
Right.
can be where the application can be built or can be differentiated just in software.
Mm.
So hardware becomes a platform rather than being one application provider. So if I mean, when I started looking at it, I analyzed, or we as a team analyzed, if you look at past 40, 50 years of history, any company, Pete, that has built one or two, one off solution or one trick pony, so to say,
Mhm.
where the chip is only useful for one application or maybe two or three set of applications,
Right.
except in networking, companies don't survive.
Mm.
See, you look at any ASIC company in past 40, 50 years, it has never seen a decade. It has never crossed a decade boundary.
Right. Right.
So the
Interesting.
only companies you see around us that survive for more than 10 years, those are all companies that build programmable chips. Very important.
Mm.
That's one thing. The other thing, chip company, because it is so, the investment required is so much more, Pete. One needs to have a complete roadmap story. If you don't have a roadmap story, it's can be funded, one of funding, but it's not a company that can sustain for a very long time.
Right.
So while trying to solve my little personal, or my personal problem, we ended up with the vision to construct a programmable chip that can provide an entire roadmap. So we ended up building our own instruction set, our own compiler, our own whole software stack.
Mm.
Kind of lots of, as you said, and many layers in the sandwich.
Right.
So we ended up building everything.
Wow.
So,
Good.
but it took very long time. The price you pay is that for building such a technology, the time it takes before we can get in front of customer is very, very long.
Right. Right.
And
Yeah, we had talked about that. Like you guys are kind of pretty far down in the sandwich. So, getting the chip designed and taped out and fabbed and then designed in, and then that has to get shipped and deployed. Yeah, it takes a while, and you need like a lot of perseverance and frankly a lot of funding to get there.
we have been able to control the funding requirements by doing a lot of innovation, even in implementation and execution, Pete.
Mm.
So our burn has been in a range of 10x less than any other of our
Wow.
colleagues or other companies that have done the same thing.
Okay.
In addition, we have been able to build a core, Pete, that can build many, many chips. And
Mm.
we have such a roadmap, and we have customers that are already signing up to that roadmap. So
Great.
that's a good thing.
So you're not only ultra low power, you're ultra low burn on your
Ultra low. That's a good way.
chip.
Ultra
That's a
low.
good one. That's cool. Yeah, I think this whole area of when the kind of the magic combination is, edge AI plus battery power plus a little wireless connectivity. That sort of turns this into a very interesting technology that's very deployable, wearable, implantable, hearable, whatever you want to call it, peel and
That's
stick,
right.
you know, type of stuff. I mean, we see it everywhere from like safety and security. So we see cities deploying like pedestrian safety cameras that are solar powered. You just strap them to a light post. There's no,
Yes, yes.
and then, but now even in the personal space, I mean, a lot of us have the watches and the wearables, but I think anyone who's had folks where are, especially aging in place type scenarios, there's a lot of potential there for combining AI in a very focused way with battery power and connectivity to kind of keep people safe and keep people alert as to what's going on. So I think that's going to be a huge space.
Actually, what we see, Pete, just to give you what we are seeing right now, this low power story is such that it actually keeps growing very big. What
Mhm.
we just experienced in past 1 year or so is that people who were building models that were being deployed in cloud, they want it into their floor. The
Sure.
ones who are deploying there in their floor, they want it on their desktop.
That's
The
right.
ones who are deploying in the desktop, they want it in the laptop. The ones who are deploying in that desktop, they want it in their smartphone or going down to almost a
The
ring.
ring. Yes.
So what it means is if I can provide low power, that means I have ability to multiply the number of core, and whatever function was available in a cloud, I can bring it. I mean, I can basically serve these customers.
Hmm.
So the
Hmm.
low power is the extreme edge to mid edge to whatever you want to call it. And what we see is that actually the applications, Pete, actually shrinking, and whatever was a non-edge application is also becoming edge application.
Right. Right. Yeah. There's this gravitational, I call it the gravitational pull
Yes,
for the
yes,
edge, right? Where it's
yes,
like everyone starts their project as an experiment on the cloud. And then
yes,
as they commercialize it, it has to get closer and closer to where the data is created
yes,
ultimately. And
yes,
there's just inevitable pull in that direction.
yes,
And for cost reasons, power reasons, latency reasons, privacy reasons, whatever, it's just inevitable. And it was funny. There was a big discussion on LinkedIn. Someone had posted about, oh, there's not enough, there's not enough data centers and it's hard to build data centers and we don't have enough power for data centers, enough water. And it was like, yeah, I mean, that is not sustainable. Like those are going to become training centers and the
that's correct.
inferencing is all going to be happening in the real world, where
Correct.
the data is created. And that actually then pulls back some of the requirements on some of the data centers, right? So if the data centers become more training oriented and less inferencing oriented and you move those workloads out, then I think that's just inevitable. And it's whether it's, years, how many months, years, whatever. I mean, it's already happening with a lot of the wearables, but it is kind of inevitable.
It is pretty much happening right now. Pretty much all the, I mean, in our case, Pete, we have our first chip that goes into small wearables like pendant, like a watch, like
Mhm.
a ring, um, like on the running track or on things like that.
Sure.
The second chip that will actually go and build the very very high speed and high performance cameras.
Mm.
So very high performance vision, which can do inference even if you're going at 100 miles 200 miles an hour, and
Wow.
still will be able to detect a very small object. So very
Mhm.
high performance high speed vision, that's our second chip. Third
Okay.
chip that multiplied the number of cores many times and goes into a small edge devices like your access point, your laptop, your M.2 cards, in your drones, in your robotics, in
Mm.
industry, things like that. So we see that people basically are taking the applications, as you said, developing them in cloud, testing them in cloud. But at the time of deployment, see, inherently, Pete, nobody, especially organizations, especially businesses, they inherently don't trust the cloud. That's fundamental.
No, I agree. It's a sort of a, I wouldn't say necessary evil is too strong of a term, but it is
It,
tempting to lift and shift into the cloud to reduce your capex, et cetera, and so forth. It's a siren song, I would say.
yeah,
But yeah, I mean, ultimately, people just would rather have more control over their data and have it on prem or just within their thing. If they can, if the business works. But yeah, but I agree.
and the operating cost actually has been one of the biggest concerns, especially of customers, especially in USA, even in India. Somehow, China data centers seem to be much cheaper.
Mm,
Uh, so people, even to save cost, they want to get out of cloud.
sure.
Other thing that is happening is that there's such a small number of cloud providers that the consumers are just scared that, oh my God, what if this my vendor decided to raise prices? I have
Mm,
nowhere to go,
mm,
right?
true.
And you may have heard that data centers seem to want want people to pay penalty if you want to take your data out of there.
Yeah, there's a little bit of a toll. Egress and ingress is always a cost, and
Yeah,
like you said, as in a running concern, especially in the kind of a lower margin consumer space, these OpEx costs can really add up. That being said, by the way, I mean, like, there's lots of great uses for the cloud too. So I don't want
correct,
people to
correct.
get the
On that.
impression, like time series insights and like data lakes and like lots of cool stuff, for sure. But sort of like especially when it comes to AI, like you were saying, it's like, how do we, really think about running the AI workloads where the data is? And yes, use the cloud if you have to, but I personally, I think of course I'm biased, but the default is you run the AI where the data is, and you don't ship the data to where the AI is.
That is correct. We have by now we have met at least customers in 3 digit who have their applications running in cloud, Pete,
Mhm.
and all of them without exception. Not one who said, no, no, go away. We have our data. We have our AI running in cloud, or we are very happy. We don't want to get on the edge. Not one said that we don't want to get to the edge.
Yeah,
To
no, for
the,
sure. Well, it sounds like you guys are in a good position. So you're based in Santa Clara, you mentioned,
yes.
and that's your primary operations. And where else are you doing business? Are you doing business across Europe and Asia Pacific, or where's your market these days?
Semiconductor companies, Pete, by default, they are global companies, right? I mean, just yesterday I was having a talk with one of my colleagues. Said, look, semiconductor by nature. I mean, unfortunately, we were talking about geopolitics,
Mm,
but my point is that as a semiconductor or AI data scientist, you are a global citizen.
mm,
You cannot possibly think of yourself as being confined or confining your application only to one particular geometry or what,
yeah,
sorry,
geography. Yeah.
geography.
No, that makes sense. I mean, it is a global supply chain. It is a global ecosystem. You can't get out of that. I mean, that's
The investment required is so much, Pete, that there is
mm,
no way a semiconductor company can survive if it has to serve only one geography. It
yeah,
just maybe China, but that's pretty much it.
yeah.
Because
No,
they
that
have
makes sense.
enough market.
That makes sense.
So
It is
we have right now customers pretty much in three continents.
okay.
Actually, four continents. Sorry,
Wow, good.
USA. I mean, North America, Europe, Asia, Australia.
Oh, Australia. Yes,
Yes.
interesting.
So
So I was going to ask you. So for people that want to get involved with your platform,
mhm.
want to get hands on with it, or how do they engage with you if they're a developer or a device builder? Like, do you have dev kits? Do you have,
Yeah.
how, how's
So
that work?
we have a full-fledged dev kit available. They can just go on our website, order a development kit. We
Yeah.
have a full stack software available, Pete, wherein people can, if they have done programming in embedded systems using any of the embedded system platform based on ARM or RISC-V, and if they know they've done deep learning programming using Python, then they are good to use our. So they
Okay.
don't need to run anything. They don't need to learn anything special
Right.
for using our chip,
Right.
but they have to know data science.
Yeah, sure. I mean, the basic stuff, but you have a tool chain, a pretty robust tool chain. You're leveraging, I assume, PyTorch and some of these
Yes,
framework for portability,
yes,
all that
we have.
stuff. Did you mention also you have an M.2 module? Is that something that people
In
can?
future, not yet.
Okay,
We'll have it in future.
I see.
It's kind of a little bit away.
Yeah.
In our case, Pete, we are building them with customers only. Means, I mean, unlike a lot of other companies who went ahead and built the M.2 card or this type of devices, And then when hunted for the customer, we are actually going and engaging with the customer first before we build them.
Yeah, I was talking to someone about customer. There's what customers say they need, and then there's customer needs, and those are different. But understanding customer needs is probably step one before you do anything.
Absolutely.
But yeah, we've seen that before. People invent cool stuff. They fall in love with their product. They go out there. They try to find customers for it, and surprise, surprise, maybe it's not exactly what.
That was actually part of our deployment strategy also, Pete, because see, most customers, they think, or most customers will tell you, if I ask them what type of camera do you need in future, most of them don't really know what they want.
No.
1 year from now, they know what they want right now, but then 2 months later that can change.
Sure.
Now, anyone who is developing hardware, there is no way I can serve a purpose of a person who just has, somebody has to be able to tell what they need 1 year later, but most customers cannot.
Right.
So we had to, hardware companies have to take a bet on proving their technology and showing people what the technology is capable of doing. We had to do that on devices that can be built with less cost, with less money. Because if you dump $500 million on building a device that doesn't sell, now you have a company that can only go one way.
Yeah, no, for sure. And and like you said, it's like I think you guys are betting on the right trends, right? Low power, low cost.
Correct.
AI where the data is created. I mean, so that's the right bet. And how it sort of manifests itself ultimately, we'll see how that works out. But it sounds like you have a really good vision for it. And I've looked through your website and stuff like that. It's really, I think you guys are really on top of stuff too. So it's really exciting to see where this heads.
And just for we are kind of in the middle of updating our website that will also show the complete roadmap of chip building, not just our first chip. So now we think we are at the cusp of announcing to the audience that we have a bigger vision, bigger roadmap.
Great. Well, hopefully if folks out there, you come and visit the website and get involved. If you come to one of our events, hopefully you'll meet someone, maybe GP himself or someone, and you can see the tech in action. It's great to meet you here virtually. I look forward to meeting you in person. And it's been fantastic. Thanks for your time.
Likewise, Pete. And hopefully see you soon somewhere.
Sounds good. All right. Talk soon. Thanks.
Take care, Pete. Okay, bye-bye.